Hello everyone, we've got another video, another exam question here on year 13 differentiation techniques. So let's have a look at this one. So it says figure 2 shows the sketch of a curve C with the equation y equals f of x, where f of x is equal to 4 times x squared minus 2 times e to the minus 2x, and it's valid for x as a member of the set of all real numbers. Show that f dashed of x is equal to 8 times by 2 add x minus x squared e to the minus 2x for 3 marks. So again, this is going to be an application of the product rule, okay? So we're going to say that we have our f of x is equal to 4x squared minus 2 e to the minus 2x. So we're going to say that that is our u and that is our v. So let's think about our u dashed. We're going to differentiate this expression here. Well, actually, we could expand it before we differentiate it. So we can say that u is equal to 4x squared minus 8. So when we differentiate that, it's going to go to 8x. Our v is e to the minus 2x. And when we differentiate that, our v dashed, remember, we multiply by the derivative of the power, is going to go to minus 2 e to the minus 2x. So we can sub that now, all those pieces of information, into the product rule. So we can say that f dashed of x is going to equal u dash v add u v dashed. So our u dashed is 8x. Our v is e to the minus 2x plus u, which is 4x squared minus 2 times by v dashed, and v dashed is minus 2 e to the minus 2x. So now we can kind of expand that, I think. So we've got 8x e to the minus 2x plus we're going to have 4x squared minus 8 all times by minus 2 e to the minus 2x. When we multiply that, that's going to go to 4 times by minus 2 is going to be minus 8, minus 8x squared e to the minus 2x. And then we're going to have minus 8 times minus 2 is going to be positive 16. So plus 16 e to the minus 2x. And then, of course, we have our 8x e to the minus 2x here. Now let's see what we're aiming for. We're aiming for an 8 outside the front, which is super encouraging. So we can take out an e to the minus 2x. So our f dashed of x, let's factorize out an 8. Let's also take out an e to the minus 2x as well. And that leaves us with just positive x from this term. It leaves us with minus x squared from that term. So let's show where these are coming from. Minus x squared from that one, and it's going to leave us with plus 2, which is perfect because that is what we need. And we can just, if we want, write it in the order so to reflect the question, so we know we've definitely got what we're after. Plus x minus x squared times e to the minus 2x. And you can see that we've derived the expression that we were asked to derive. Okay, that's great. So we've derived that expression, so that's all done. Hence, so that's part A for 3 marks. Part B, hence, find in its simplest form the exact coordinates of the stationary points, okay? So we now need to differentiate. Oh, actually, no, we need to solve this because this is the equation of the gradient. So we need to set this equal to 0 and solve it, okay, in order to find out what the equations of the stationary points are. So for our part B, what we need to do is we need to set it equal to 0 and we're going to solve. So for part B, we're going to say that 8, open brackets, 2 plus x minus x squared times by e to the minus 2x is equal to 0. And then we're going to solve that, okay? So let's have a little think about this. The first thing I would say about this is notice this here. This is really common and comes up in loads of exam questions. This e to the minus 2x here, if we think about the graph of what that looks like, it's going to look something like that. And as x tends towards infinity, e to the minus 2x tends towards 0. But because it's an asymptote, it never actually gets there. Okay, so this is actually never going to equal 0 for the purpose of this equation. So the only way that this expression is going to equal 0 is if this quadratic is equal to 0. Okay, so we've got to solve to add x minus x squared equals 0. That's what we've got to solve, because that's never going to equal 0 because of this reason here. I'm going to take it over the other side just to make it easier to deal with. So we've got x squared minus x minus 2 equals 0. We're thinking about two numbers that times together give us minus 2, but add together to give us minus 1. So that's going to be x minus 2 times by x plus 1 equals 0, which gives us solutions of x is equal to 2 and x is equal to minus 1. So they are our two values of x that correspond to the turning points, okay? And I think I think it says, hence find in its simplest form the exact coordinates of the stationary points. So that means we need to find the corresponding y values that match our two x values, okay? So let's do that now. So we're going to now look for the corresponding y values that match them. So the first one we had was when x was equal to minus 1. So that needs to go into our f of x, okay? So we need to work out f of minus 1. So f of minus 1 is going to be 4 times by minus 1 squared minus 2 times by e to the minus 2 times by minus 1. Okay, so that is going to be 4 times by minus 1 squared is plus what? Plus 1. And then plus 1 times plus 1 take away 2 is going to be minus 1. So that is going to be minus 1 there. And then that is times by e to the, that's going to go to 2 there. Okay, so that gives us the coordinate of minus 4e squared. So the coordinate of the first turning point, which if I just indicate where that is, let me just indicate where that is here on the sketch, this one here. So that one there has the coordinate of minus 1 minus 4 e squared. Okay, so that's the coordinate of that one that I've just indicated on the diagram. Let's do the coordinate of this next turning point here. This is the one that corresponds to the x is equal to 2. So we need to work out f of 2 for this one. So this one is going to be 4 times by 2 squared minus 2 times e to the minus 2 times 2. So that is going to be 4 times by 4 minus 2 times e to the minus 4. And that is going to be 4 minus 2 is going to be 2. So that is going to be 2 times 4 is going to be 8 e to the minus 4. So that means that our second coordinate is going to be 2, 8 e to the minus 4. So we've now found both of our coordinates of the turning points of the graph. Perfect. Now let's have a look at the next bit. It says, the function g and the function h are defined by g of x is equal to 2 times f of x, and h of x is equal to 2 times f of x minus 3. Find the range of g and the range of h. Now, what we've got to do here is think about what kind of transformations are represented by these two equations. So g of x is equal to 2 times f of x. Let's write that down. So g of x equals 2 times f of x. Now, the type of transformation that we've got here is this is a transformation of the form a times f of x. And you may remember that that is a stretch of scale factor a parallel to the y-axis, or you could say in the y direction, okay? So what that means is that our coordinate, we need to think about the range, okay? And actually, the coordinate that's going to be governing the range is, if I just change this now so I can draw a straight line on here, is going to be this line here. Okay, this is the one that's going to be governing the range, because this one's not relevant because it's kind of like lost in the fact that this one goes up to here. So where the range, in other words, what's coming out of the function g of x is going to be from this low point here and then all the way up to infinity up there. okay, going all the way up to infinity, because that curve carries on up there like that. Okay, so therefore, in order to determine the range of g of x, we need to know what's the coordinate of this turning point here on the function g of x. And we know what it is in f of x. We know that in f of x, it has the coordinate -1, -4 e squared. That's the coordinate of it in f of x. So when it gets stretched by scale factor 2 parallel to the y-axis, the x-coordinate remains unchanged, but the y-coordinate is going to be times by 2. So our g of x turning point at that point is going to be given by -1 -8 e to the e squared. So it's going to be -1 -8 e squared. So that is going to be the coordinate of that point on the stretched curve g of x. So therefore, we're being asked to find the range. So the range is, it's going to start at -8 e squared, and it's going to go all the way up to infinity. Okay, so it's going to be that we could say that g of x is going to be less than infinity, but it's going to be greater than or equal to -8 e squared, and that is going to be our rate. There's other ways we could write that. We could write it using that notation where we can say like this. You could write -8 e squared comma infinity. That's another way of representing that same thing there. Okay, that kind of square bracket means greater than or equal to, and that curve bracket is a strict inequality. So that's an alternative way we could write that answer. And yet a third way we could write it is we could just say g of x is greater than or equal to -8 e squared. So either that way or that way or that way are three valid ways that we can answer C part 1. Let's look at the next one, C part 2 now, the range of h of x. Now let's think about what's going on here, h of x. So we have got a stretch of scale factor 2 parallel to the y-axis, and then we've got a translation by vector 0 -3. So first of all, we have a stretch of scale factor 2 parallel to the y-axis. Then the whole thing gets translated down by 3. Well, we know from part 1 that the coordinate of the turning point after it's been stretched by scale factor 2 is -1 -8. So then when the whole thing gets moved down by 3, we've got to think about where that is going to take us. Okay, so let's think about where that is going to take us and what implication that is going to have. Oh, now notice actually that they've changed the domain for the f of x. Notice that they've suddenly put, let's go back to our annotations like this. Notice here, look, this is now no longer x is a member of the set of all real numbers. It's just x is greater than 0. So this bit over here on the left has now gone. Okay, so that bit's vanished, and what we're left with now is just this. We're left with this curve like that. Now this changes everything, okay, because in our f of x now, our range for f of x is just going to be in between these values here. So if we're going to find out the range of h of x, let's first of all find out what the range of f of x was when x is greater than or equal to 0. Well, we know the coordinate of that turning point. We found the coordinate of that turning point already. We found that the coordinate of that turning point is 2 and 8 e to the -4. Okay, so that was the coordinate of that point there. So we've got that. So now we need to say, okay, what is the value here? And this is going to be when x is equal to 0 in f of x. So we need to work out f of 0. So that's going to be 4 times by 0 squared minus 2 times by e to the -2 times 0, which is going to be -8 times by e to the 0, which is just going to be -8. Okay, that's fine. So we can say that this coordinate here is x is 0, or rather, yeah, x is 0 and the y is -8. So we've now found the coordinates of those two turning points, which means that our range of f of x is that f of x is less than or equal to 8e⁻⁴, but greater than or equal to -8. So that's our range of f of x. So now we can turn our attention to the h of x. So we've got, first of all, we need to do turn it into a stretch by scale factor 2 parallel to the y-axis. Now what that's going to do is a stretch of scale factor 2 parallel to the y-axis is going to have the effect of doubling all of the y coordinates. Okay, so if we have 2 times f of x, then our range for 2 times f of x is going to be, it's going to go all the way up to 16 e⁻⁴, and it would come all the way down to -16 there, because we'd have to double that. Okay, so that would be our range for 2 times f of x. And we're almost there now, because our h of x is equal to 2 times f of x -3. So we just need now to look at our coordinates, and we need to take 3 off these. So we can say that the range of h of x is going to be less than or equal to 16 e⁻⁴ take away 3, because the whole graph is getting moved down by 3. So we're taking 3 off that one. And then we need to take 3 off this one. And if we're at -16 and we take off another 3, we end up at -19. So that is our range there of h of x. h of x is less than 16 e⁻⁴ -3, but greater than or equal to -19. Again, you could write that in different notation if you wish. So for example, another way of writing that is we could use those square brackets and write -19 comma 16 e⁻⁴ -3 like that. That's just an alternative notation representing that, but you get the full marks for both of those. That was quite a nice question, that one, I think. I hope that you found that helpful, and I will see you in the next video.